Philippe again, so from Oracle OAC Product Management, for those who were not there in the previous session. And I am really excited to talk to you about the capabilities of machine learning with Oracle Analytics, and in particular, its integration with Oracle machine learning. So for this, I will spend the next 45 minutes and 40 minutes, and I'll try to give you demos of this because I think it's really exciting. And talking about multiple aspects, but before that, I just want to stress one thing. You will see several capabilities of machine learning as part of Oracle Analytics. And these address really various profiles and roles in an organization. They address distinctly, clearly, business analysts to begin with. And business analysts are actually not even supposed to know anything about machine learning. They also address what let me call citizen data scientists or domain experts. And the citizen data scientist is the profile which is domain expert, business knowledge, departmental, that has moderate understanding of statistics and machine learning, but has no coding skills. So a period that is smart enough to get in trouble, but doesn't have is not equipped with the coding capabilities, whether it's Python or JavaScript or anything, or SQL to do machine learning and real data manipulation. And then obviously the data scientist who has a great understanding of all of this capability of this science, but may have a more limited knowledge of the domain and the business itself. And the data scientist is a resource that often sits at a corporate level. It's not as present in all these departments. So OAC address most of these profiles, or actually all of these profiles, with different functionalities, obviously. And these different functionalities could be grouped into three areas. One which is more business analyst facing, which is augmented analytics, which is, let's qualify it as a right-click machine learning. If you are an analyst and you need quick results now that are leveraging proactive machine learning, there are features in OAC that exactly do this, that allow you to either get knowledge and insights without worrying about how it is done behind the scenes, just get to the results quickly with a right-click sort of. If you're a citizen data scientist or domain expert and you want to scratch the surface a little deeper, OAC-ML then also offers you the capability of really getting in troubles and building models and training models and running models and real building scenarios and doing different qualification of your model, cycling through this. You'll see this in a minute. But all of this without requiring you any coding skills, just in a way that is intuitive and friendly for you to play with. And if you're a data scientist, then you may be interested in, first of all, exposing the result of your work to business users and exposing it in a way that they can make sense of and then they can make value of. You may also be interested the other way around. You may be interested in knowing what business users are using, what are their data sets, how they express their requirements, and exactly what their need is. And this is crucial for many data science processes, define the goal properly and understand exactly the need of the business users and interact with them frequently so that you can refine that. And that's where OAC will help you in both the ability of exposing your work as a data scientist to the masses, as well as the ability of collaborating with business users to catalyze and make the whole data science cycle more fluid and hence more higher returns. So if I actually, let me go back one step. I will not have time to talk to you today about augmented analytics. This session is mostly about the second and the third line, machine learning in OAC and machine learning integrating with Oracle OML, Oracle Machine Learning. OML is really database machine learning. So the capability that exists in databases to define models and apply them. So let me start with the second row in this table. The machine learning is a cycle. Well, if you've already produced machine learning models, you know that, and the cycle, that's just one representation of it, where obviously it starts with some data and make it exist somewhere in the system, then tune it and prepare it and then explore it. Step 2 and 3 are critical. Understand the data, prepare it, tune it, fix it, edit it, simplify it, aggregate it, you name it, join it if you need, and understand it, and then do your model development. And as you're doing your model development, I don't want to say it's shooting in the dark, but eventually you're evaluating your model, and from step number 5, you very often go back to step number 2, perhaps step number 1, and cycle through this multiple times. And eventually, also, once you're happy with the model, deploy it and let it be used where it needs to be used. Well, OAC machine learning, so OAC includes a machine learning engine as part of it. And the value that it brings is that it makes this entire cycle friendly to any business analysts. So I'm pretty sure if you have never used OAC for machine learning, you probably will not believe that you can do all of this, 1, 2, 3, 4, 5, 6, without writing a single line of code. And you can do all of this without knowing much of machine learning even. You can do all of this with a user-friendly, intuitive experience, declarative experience, no code. So what am I talking about? You can certainly load a lot of data in Oracle Analytics Cloud. By the way, I keep saying Oracle Analytics Cloud, but what I'm showing you is true as well for Oracle Analytics Server, the on-prem version of Oracle Analytics. Obviously, you can connect to a lot of types of data sources. You may have heard a little bit of what we were saying earlier on. You can bring any type of data and load it into OAC. You can connect to the semantic layer as well, which is the repository that has been built by IT. And you can blend all of this, irrespective of where it's coming from in its format. You can get to load and use this data. You can prepare this data fairly easily. There are data flows. So data flows are sequences of different steps that you create as a user just by dragging and dropping steps into that UI, and you get a tree like you're showing here where, hey, I have this Excel spreadsheet and this is coming from some system and I'm joining it and then I'm branching it and I aggregate it, or I suppress column and I edit columns. It's all declarative, there's no code. It's almost fun to build. And that runs in a batch mode on your OAC engine. You can do calcs, you can do groupings, you can do all sorts of things. So there are multiple steps there. So that preparation step is also complemented with automatic prep and enrichment. You saw, maybe you saw me in the previous session showing you the system is going to prompt me when I load some data. It will tell me, hey, you should do this, you should do that. We recognize this column as like this, and maybe you want to add some more information about the city. Maybe you want to add the country, the population, the zip code, what have you. That also comes as part of the data prep. Obviously, once you have all of this, it's fairly easy for you in OAC to go and visualize your data and get your own little insights of it. I mean, your own little grasp of the data before you do anything. Visualizing it is just dragging and dropping objects and in the canvas, and that's as simple as that. You can also leverage some of the analyst-facing capabilities of OAC. So there are features that will tell you if I look at attrition, or if I look at opportunity or claims fraud risk as a fraud flag, yes or no, can the system tell me what correlates with that? What is driving the fraud flag, yes or no, in my data set? So can the system help me explain the fraud flag status? So that is a feature that exists as part of OAC, which basically outputs the main features driving a given column. So we call that feature explain. That is a part of the offer that helps you get a grasp of your own data and understand, so that you don't shoot in the dark, but you have some information about it. Once you're comfortable with understanding your data, there is a machine learning training platform as part of OAC, and that's part of these data flows. So if I start with the data, I can go and train different type of models. So you can see here, I can train maybe just a prediction or a classification, whether it's multi-classification or binary classification or a cluster. And when I do this training, the next prompt that comes up to me is, okay, you decided that you wanted to train a prediction, a numeric prediction. Sales, maybe you want to train a model that will predict sales or predict whatever, some numerical value. Well, then you will have to pick between a few algorithms that we have to do this as part of OAC. And once you pick an algorithm, like here in this case, CART, regression tree, right, will prompt you with a minimum. So the picking the algorithm is just a wizard box that comes up top of the screen. And once you've selected this, then we're telling you, look, there are some parameters for this algorithm, but we're going to offer you a default for it. All you need to tell us is, what is it that you want to predict? And if you want, you can override some of these parameters, which are basic, or you can leave them as is. And if you're an analyst or a citizen data scientist that doesn't really want to play with this at this point, you can leave the 3 depths to be 5, and that's it. And then you can come back to this and change this easily. Once you have trained your model, a lot of options exist for you to see the results. First of all, it generates some metadata information about your model. In this case, a confusion matrix or a bunch of statistics about the model itself. Second, you can also apply it to your own, actually, you can apply it directly on a visualization. So when I look at my real actual value in my test data set, I can compare with different models, a green model here and a blue models that have a prediction, and I can visually immediately compare which one is closer to another one. In this case, I'm looking at it over time, but obviously this is not a time forecast. It's a model that has a lot of different parameters to it and input to it. You have access to all of that information to let you understand that, yeah, this model is using so many columns as input, and it's yielding that type of results. If you're not happy with what you're seeing here, it's very easy to go back there, fix your data preparation, perhaps add or remove columns in your data flow, and then recycle your model development and see what else and tune this. And once you're happy, deploying is as easy as saying, okay, I'm done with building this model. Ziga, you're a user of this environment as well. You can go ahead and use it. What do you mean use it? Well, you can go ahead and apply this model to your own data set. It's ready. As long as your data set has the input columns that are needed by the model. So that experience is completely declarative and is helping me as an analyst to get my hands into machine learning quite easily and quite rapidly. What is the benefit? The benefit is that I don't need to mobilize data scientists' resource for this. And I can get to initial results quickly because I have the business understanding of what I'm trying to do. And perhaps if this is valuable, I can go to data scientist team eventually and say, look, this is what I'm trying to do. This is where I'm landing. Can you help me? But at least I will get there with a really sharp defined use case and need. And typically the data scientist will be happy to understand this. On the other hand, the data scientist could also use this as a quick way to have his initial modeling aspects before he really starts to invest into a more larger and deeper data set preparation behind the scenes. Now, this is good for citizen data scientists and analysts. But really, this is not the platform where a data scientist will have all of the power and all of the depth that he needs for building models. Clearly, we're not recommending that data scientists build their model on OAC, or they may draft their models on OAC and then move on. But they have other platforms in Oracle to build very strong data science processes and infrastructure. One of them is Oracle Machine Learning. Oracle Machine Learning is the infrastructure that the data science machine learning, data science infrastructure that gets shipped as part of any Oracle database for free. So you have a platform, a machine learning platform, as part of ADW on the cloud, as well as any other on-prem database in Oracle, and that's free. And it has a lot of different algorithms and capabilities. And it's very powerful. And actually, in addition to being very powerful, it has the ability to, actually, it's not an ability, it's property. It runs the algorithms where the data exists. So your data is in the database, you don't move that data, you just create the algorithm, or you create the model on the database, and the data resides where it is, it never moves. So that's very powerful. Well, what is possible now, or in the past 5 months, is the ability to consume what data scientists have built in the database in OML via OSC, along with also consuming more than this, database analytics SQL. So let me actually briefly show you the machine learning OML, the first line here. If a data scientist has built models, machine learning models in OML, then me as a OAC administrator can simply register this in OAC once the data scientist is done with building the model. And once I have registered this, then all my OAC users can go ahead and apply this. And as they do this and they run it, nothing steps out or is removed from the database, is moved from the database. It all executes in ADW. Why don't I give you a live demo of this rapidly? So this is not the screen that I want to start with. Hopefully you can see my screen. Let me make this. Okay, this is the homepage of Oracle Analytics. And I'm the administrator here, and let's pretend that Ziga has built some models in Oracle Machine Learning in the database. So what we're going to do is simply go in Oracle Analytics and say, hey, I want to register a machine learning that Ziga has built. So this is consuming something that already exists in the database. When I do this, I'm being prompted with, okay, well, tell me which database it is that you want to register this from. Well, why don't I go to my ADW, my cloud database here. Maybe I should log in again. That's probably the reason why this has been idle for a little bit too long. Let's see if this works this time. Okay, so then let's try another one. We'll get one to work. How about this one? All right, so let me use a local database here. It's an on-prem database as opposed to a cloud database. So here is a list of models that Ziga may have built in this database, and they have sort of technical names. I'm not sure I want my users to see this, but to begin with, what is this? So when I click on one, this is telling me that this is a classification, a decision tree model that runs a classification, and it's targeting insurance propensity to buy, and it has inputs columns that are made up of that's what it needs, and it produces outputs, which I will talk to you in a minute. And these were the parameters that Ziga used to run it. Maybe I want this model, maybe I want another one. I'll recognize the one that maybe Ziga has pointed me to, and let me say this is my demo model, okay? And I'll register this. So that's it. This model is registered in the database, and no, excuse me, in the OAC, and users can now go and use it. How do users use this model? So let me swap role now, and I'm not the administrator anymore, I'm a user. So the user here is going to create a data flow. Data flow is that little diagram that I was showing you earlier on where we prepare data. Okay, so I'm going to create one. I'm going to say, so let's try a data set. So you know what? I'm going to swap back to my demo that just didn't work, right? So I'm going to go and call for, I think it's attrition data, employee attrition actual. So let's see if we can run a model that has been built in the database that calculates attrition, okay? So I've connected, I've added a data set here that is in a database. And I'm going to say, well, let's add a step. So you remember I was telling you we can do a lot of things in data flows. We can transform, remove. I could actually do some of that stuff right now, but for time's sake, I'm going to move on and go to apply model. Before I click on this, if I wanted to train an OAC model myself, I could. That's where I would come. You see this? In this demo, I'm just using a model that I pretend that Ziga has built on the database. So I'm going to apply the model, and there I see a lot of different models that have been registered in OAC. Remember, I am a business user, right? So what I see here are models that were built in OAC. You can see they don't have this little button, right? So this is a model that was built in Oracle Analytics. This is another model that's built in Oracle Analytics. In each of these models, they have different purposes and they have different inputs and different outputs. But I also see models that have been built in the Oracle database. And the models that I'm seeing here are the ones that belong to the same database that my data set belongs to. So let me say this is a naive-based attrition model, okay? I'm going to just use this one, and I'll say okay. So now we're saying that we want to score my employee data set with this model. And this is the data here in my employee data set. You can see it at the bottom. I'm going to hide it for a second, just to be a little bit more clear. So what does this model, attrition model NB, require? It requires all these columns. And luckily, all of these columns also exist in the data set that I'm using here. So it found out that, okay, well, I found the columns, they have the same name, the same type, so I took the liberty to map this already. Well, maybe I want to override this and change this with some other thing. Well, I'm not going to do this, right? So I'm gonna leave it by default. But if I didn't have this mapping, then I could do it manually. And there are some parameters. I'll skip that. And there are some outputs. So what is the output? A prediction and a probability. And cost, and I'll remove cost. And there is a lot more. And I'll come to this in a minute. Let me just, my environment has a little issue. I will unflag all of this. This is a development environment. You'll see me talk about this in a minute. Just bear with me. Okay, so the basic output that I want is simply the prediction and the probability for this. And I'm just going to not do anything, go simply to saving this as a data set, which I will call a demo attrition, let's say. And of course, it will create a table in the database. And I have to give a name to this table, right? And it will create all of these columns, and I can override these columns here. I can say age is not a metric, it's an attribute, and I will have my prediction here, and I will have my prediction probability. I want this to be a measure, but I want this to be average. And that's it. I must just run this data flow. So I'll call this the demo attrition run. So the data flow is generated and it's running right now. And what's going on really is that OAC is sending the information to the database, and proper SQLs are being run in the database so that the model in the database is applied to the data set that sits in the database. Nothing is happening in OAC. And as you can see, it was pretty fast because obviously no data transition, and database has the capability of parallelizing application of model. Now, if I go into my data sets, hopefully here's our demo attrition that was just created. I'm not sure why the timing is 8 minutes ago, because we just did it. If I click on it, immediately I can see that, look, I started with my data set, and I now have all my predictions. So why don't we look at prediction by age, for instance, right? So why don't we do this? And maybe we want a number of employee. Do we have employee count? Yes. So why don't we do this? I can visualize. Hang on. Let's simply have this here. Okay, by age, the prediction for attrition versus the prediction for non-attrition, yes or no. I obviously can slice this. I can also show this by probability, right? So if I do prediction equals yes, so I'm going to put prediction as a filter. Now I will see which age is most likely to attrit. So that's interesting analytics, and I can obviously slice this by anything at this point, such as marital status or anything. This is my business data, and I can represent my prediction using the model that was built by data scientists in OAC, and click and drag and build results with it pretty quickly. And what we have done here is that we as analysts were able to leverage this model in a very simple way, right? When we built the data flow, we picked a data set and we applied the model to it. And now we're just visualizing it. So that's pretty powerful. Now, one more thing I want to take a quick look at is that, so this is GA, this is already there as part of OAC. You can already, your users can already just consume the models that have been built in Oracle Machine Learning as is. Okay, these were slides that I had as a backup if the demo didn't work. Now, what's coming next? Soon enough, you'll have a little bit more information. And I want to stress it for a minute because it's very important. So first of all, as part of the model itself, actually, why don't I demo this to you very quickly? We uploaded a model. Okay, so I'm just going to go back to my model here. in my machine learning tab. That's the model that we uploaded a moment ago. There is a way for me to see once the model is in OAC, is registered in OAC. I have a little bit of information about it. I have, you know, the metadata of it, you know, what we saw when we registered it. It's helping me understand what things are doing. I can actually give access to this one to some users and not to others. I can permission this, obviously, but I can also look at a few information that are interesting. This is telling me that this model is a decision tree that computes classification. And a certain number of tables or views exist in the database about exactly this model, and they have a lot of information for me. So with this data here, I can go directly into these tables in the database using OAC. Now let me go back to my deck. That's where I was. Oh. And represent information about my model. So I can represent, in the case of a tree here, I can represent a tree branch. For each tree branch, I can see exactly what are the conditions in the tree, what is the parent, what is the node condition, the confidence prediction, the statistics. I can understand what are the main drivers of this model and how it's computing the prediction. So this is metadata about the model. But more importantly, there is also something else that's coming up. You saw me unclicking it a minute ago, is additional outputs. What are additional outputs? Additional outputs are all these 20 fields you saw me unclick, which are providing me with two things: prediction set values and prediction details. What is that? So very quickly, prediction set values is simply, look, the Oracle machine learning, the database machine learning gave you the most probable outcome and its probability, but perhaps there were other outcomes. Perhaps the classification had multiple classes, and maybe the most probable outcome was to be high lifetime value, but maybe there are 4 other outcomes, and maybe the most probable one was there because it had a 30% probability, but the next one could have been high risk as well with 29% probability. And the next one, again, could have had some decent probability as well, and so on. As a business user, I'm interested in that information. I don't obviously want to know only the most probable. I want to know the span of all the probabilities for different classifications, for instance, or outcomes. So this is the prediction set value, and this is very helpful because it helps you then understand exactly. Well, this model was not just telling me that this individual is probable to be at a high risk, but also that the real place where the cursor was for that decision. The next part on the right, sorry, is even more interesting and exciting to me. Prediction details value. The database machine learning model provides for each record, not only, actually for each record, it provides the top 5 attributes that made up the probability or the outcome. So this is not just your model. Let me go back one slide. Your model is using these attributes here, the blue and the greens, to make a prediction. Okay, good. I see that product category is important, product container, group subcategory. Okay, got it. That makes up the way that the model does this computation. Cool. But for my data, which one of these attributes for each record was the most important? My data may be slightly skewed or different, or I am interested not in knowing what the model equation is. I'm interested in knowing for each of my record exactly what are the parameters that made up the outcome. So let me go in a screenshot of the results. What you see here is a table with my employee number, the prediction that the model came up with, and the probability, and then these attributes that made up the most important reason why this person was predicted as not attrition, because his overtime was yes, marital status was single, and stock option levels this and this and that. Now that other person had a different outcome here number 4 because of different reasons and so on. So now that I have this detail, I can understand exactly for each individual what made the prediction be such. But I can also aggregate this. So now I can understand that, look, in my data set, which could have been different from whatever data set was used for training it, well, age comes up as the most important driver. And then total working years is the second one, and job involvement the second one. But guess what? Maybe this is different for different departments. So if I look at a marital status, I'm gonna click on divorced here. Then the whole chart now only, oh, actually I clicked on married, sorry. So it only shows these things for married. So now I can see that for a chunk of my population, the attributes that really drove these results are different from what I thought they would have been. This is explainability. So with OAC and with OML, I can not only predict values, but I can also explain exactly. So let me click on something else here. I'm going to click, I think, on divorce, if I remember well. See, so divorced, you can see, let me go back. The charts are changing from divorced to married. And if I keep going on and filter on department sales, this is different charts when I filter just on sales and so on. So I can explain exactly what were the most influencing factors in the model when I applied it. So that's a very powerful capability of OML and OAC together. I'll move on for the last part of my presentation for time's sake. So that capability here is immediately next. You will see this in 5.9, this capability. In fact, yeah. So let me move on. One more thing I want to highlight to you, database analytics. In the data flow a moment ago when I was demoing, I use the apply model node, but I didn't highlight this one, which is database analytics. I had a data set, and as part of this data set in the database, then the system came up and say, hey, look, your data set is in a database, so why don't you, we have a few capabilities here in the database that you could use. Today, you can use some dynamic clustering or sampling or unpivoting. So these are, or anomaly detection, these are SQLs that are available in the database that you could use. The benefit of using it in OAC is that you will not need to, if I just briefly show you that, you will not need to know anything about SQL. So if I go back to my data flow here, and if I just delete these nodes, and if I just go and select this database analytics, and let's say we want to select some dynamic anomaly detection, what's that going to do? Well, it's going to ask me for something which is tell me a partition column and tell me what is your output and save it. Completely declarative. If I wanted something else like sampling, then give me a percentage. Now, in GA version, you can do all of this, which is dynamic anomaly detection, clustering, and sampling. And when you do this, obviously, this all ships down to the database. In the 5.9 version, you're going to have two more, frequent item sets and text tokenization. What is text tokenization? Text tokenization allows me to extract from a text field so if I had a text column, and I don't have one here, so for time's sake, I'll probably skip the entire demo, but all I have to do is specify a text column and maybe a reference to my business data. So what is my row ID? And this will output my top 50 tokens in the text. And let me show you what this looks like. I think I have a data set. I already run that data flow, so I just want to maybe we are looking for tokens. So here are tokens on claims, insurance claims descriptions. And so we had a insurance claims data set, and now I've asked for tokenization of it. This is telling me that these are the top 50 tokens, and this is how many times they appear, and in how many rows. So the most important one is vehicle. But because I have this reference to the data set here, I can easily join this output back to my claims data. So this is the result that the database has provided me, okay? So when I did this data flow, it said, yeah, I'm gonna provide you with the tokens, and here they are. But you can now join this to your claims data and do this analysis using your business data. So I'm now joining it to my business data here. So remember, I used raw ID here in my data flow. So I have the raw ID in both data sets. And now I can slice and dice my tokens, not only in general, but by my business data. So these are my tokens, right? So let's just use a different visualization here, like this. Now, okay. Now, is this any different if I look not at occurrences, but claim cost? Okay, so which word that appears in my claims is the most closely to me? It's brakes, it's not vehicle. What if I slice this by, do we have vehicle make, right? So now I'm looking at the results of okay, what if I'm just picking a few folders of makes here, and then let's say for these makes, I want you to show me the tokens. So I'm going to make this. So I picked, why don't I, like W and some makes that probably have some more data in my demo, and I'll remove this. So now we can see that the words for Daewoo are quite different from Acura. The cost tokens are different by different brands. This is tokenization, database analytics blended with business analytics. And finally, the one last that I want to show, and then I'll have to stop for time's sake, is that this will complement pretty soon with another one. I won't have the time to really demo it, but I will show you. So you see this list here. This is the same database analytics list growing bigger and bigger. You will soon see graph capabilities. So shortest path, ranking, subgraph clustering, using the database graph capabilities on your data set. So this is complex SQLs and analytics in the database that is made simple for you as an analyst via OAC, that allows you to do pretty powerful representation of your data and get into business value immediately. So I've run out of time here. I think we're at the top of the 45 minutes, but I'll stick online to take any Q&A questions if you have, and I thank you for your patience with all of this. Ziga, back to you.
Thank you, Philippe. That is really another major step in the functionality for machine learning support. Excellent. Yeah. Thank you for this. I don't see any open questions. So if anyone is still has some questions, feel free to ask. There are no questions coming in. So you're also invited, if there are some other questions popping up, you can send email probably to Philippe directly or to the conference organizers. Yeah, thank you, Philippe, for your time, for your presentation. I think it was really revealing for me, but I'm actually working with Oracle Analytics on the daily level. Must say that some things are really impressive.
Thanks a lot, Ziga, for the opportunity and for your interest.
And